This is lesson 1.3, what's a widget? So the first thing that we need to know is that a right angle is one that's measuring 90 degrees. There are a couple ways that when we're talking about an angle being 90 degrees that can be signified. One way is that they can put the number 90 in the angle, and the second way is that they can put a box in the corner of that right angle. Those are really the only two ways that you know, other than words perhaps, that the two segments, lines, or rays are perpendicular. And so a right angle measures 90 degrees. The second thing is that we have an acute angle, and that's one that's in between 0 and 90 degrees. And as long as you have a degree measurement there, or you see that it's less than 90 degrees, that would be your acute angle. An obtuse angle is one that measures more than 90 degrees, but it's less than 180. For example, down below on the right-hand side, that's an obtuse angle. And a straight angle is one that's exactly 180 degrees. And those are the four kinds of angles when we talk about the size of an angle. Definitions are used by creating three steps. Number one, you want to classify your term. For example, you would say that a square is a four-sided figure. Now, of course, that's not the only thing to do with squares, but that's a start. Differentiate that term from other ones. So then, in addition to that, you would say that there are four congruent sides. And then, in addition to that, you want to also test using counterexamples. For example, a rhombus satisfies both of those things. Four equal sides or congruent, and it has four sides, of course. So you would actually need a third piece saying that there are four right angles in order to make sure that you knew that you had a square. So those are the three steps. Down below, we talk about two different kinds of sets of lines that are kind of unique. One is a set of parallel lines, as you see down here below. Those are a pair of lines that are in the same plane and never intersect or meet. Perpendicular lines are lines that meet at a 90-degree angle. So over to the right we see perpendicular lines. Remember that in order to know that they are perpendicular, you're going to want to see either the 90-degree measurement or a box in the corner in order to indicate that those two lines are perpendicular. Some other definitions that we get into are things called vertical angles. So vertical angles, vertical angles are those angles which are formed when you have two intersecting lines. They have a common vertex, but not a common side. Down below in our picture, we will notice that we have two sets of vertical angles. One set is angle 1 and angle 3 that we talked about, and the second set is angle 4 and angle 2 that we talk about. Kind of the nice thing about vertical angles is that we know that they are congruent to each other, so that's kind of a wonderful thing. That means that if I'm talking about these angles, I can tell you that if angle 1 is 130 degrees, that means that angle 3 will also be 130 degrees. If I tell you that angle 2 is 50 degrees, that means angle 4 is also 50 degrees. So really nice to be able to use that. Linear pairs, on the other hand, are those pairs which, when we look at them, they have a common vertex, just like the vertical angles, but they share a side and form a line. So for example, in the same picture that we were looking at, we have multiple linear pairs. For example, angle 1 and angle 2 together form a straight line, share a vertex, and add up to 180. But we also see that angle 2 and angle 3 form a straight line and also share a common side, that's a ray. We see also that angle 3 and angle 4 are a linear pair. And last but not least, we can also see that angle 4 and angle 1 are a linear pair. So around two intersecting lines, we have four sets of linear pairs. Remember, they have a common side, They form a line and have a common vertex. They add up to 180 degrees is another way to say it. Down below we talk about something that's very common to talk about in geometry. It's the phrase of being complementary. The phrase complementary, when you're talking about angles, means that they have a sum of 90 degrees. So it doesn't even matter if you're attached or not attached as long as you add up to 90 degrees. Down below, on the left-hand side, if you look at these angles, if I were to tell you that angle 1 was 60 degrees and angle 2 is 30 degrees, these two angles are complementary because their sum is 90 degrees. So angle 1 and angle 2 are complementary, they add up to 90. However, notice that in the second group, 3 and 4, they are not attached by a common vertex. That's okay, because if we have a 75-degree angle for angle 3 and a 15-degree angle for angle 4, those two angles are still complementary as long as their measurements add up to 90 degrees. So it doesn't matter if you're attached. When we were a linear pair, it did matter. But here, it does not. One thing I should have also mentioned about linear pair, in linear pairs, you can only have a total of 2 angles. Why? Because it uses the word pair. Not 3 angles, 4 angles, 5 angles, just 2. Likewise, we can also talk about something called supplementary angles. Now, supplementary angles means that you add up to 180 degrees. So as we look at the different examples here, we'll see some examples and some non-examples. For example, in angles 1 and 2, if we know, first of all, that they form a linear pair because they share a common vertex, have a common ray for a side, and make a straight line, we know that they're a linear pair and can also be called supplementary. For example, maybe angle 2 is 120 degrees and angle 1 is 60 degrees. So those two are supplementary. They do not have to be attached, though, to talk about supplementary, as they do with linear pairs. They just have to add up to 180 degrees. So in the second group, where we look at angle 3 and angle 4, if angle 3 is 30 degrees and angle 4 is 150 degrees, even though they are not attached, they can still be called supplementary. So they do not have to be attached. Remember, there has to be 2 angles in order to be called supplementary, not 3, not 4, so on and so forth. Look at angles 5, 6, and 7. If I were to tell you that in that group, off to the right here, that I see something like a 60-degree angle, a 50-degree angle, and then maybe a 70-degree angle, which totals up to 180 degrees, I can't say that there is a linear pair or that there are supplementary angles because there are 3 of them that total that. There has to be only 2. So in the orange, we have a non-example, or an example of what's not supplementary, also what's not a linear pair. In angles 8 and angles 9 down below, we notice that both of these angles are obtuse, meaning that they're more than 90 degrees, but less than 180. For example, I might have angle 8 be 160 degrees, and maybe angle 9 is 150 degrees, and that total is definitely more than 180, and so I know that angles 8 and 9 are not supplementary. So something that's important to know, number 1, they have to add up to 180, number 2, that can only be 2 angles.